Hi students, in this video we are going to solve question number 2 from the exercise 10.1 of the chapter straight line from the first PU syllabus. You want any sum, you want any derivations from this chapter, go to playlist and look for straight lines. You will be able to find all the sums and derivations. Now we are solving the question number 2 and the question goes like this. The base of an equilateral triangle with side 2a lies along y-axis. There is an equilateral triangle whose sides are of the length 2a. The base of the triangle lies on y-axis such that the midpoint of the base is at the origin. The midpoint of the base is at the origin. Okay. Find the vertices of the triangle. We need to find the vertices of the triangle given these data. That is, it is an equilateral triangle whose sides are of length 2a and the base is along y-axis and the midpoint of the base is at the origin. These are the data given. So we are considering the triangle to be ABC with side 2a and we are considering the rectangular coordinate system. So this is the triangle that we are going to consider. It will be like this. The base is along y-axis and this is the triangle. And the midpoint of the base is coinciding with the origin. So this is as per the data. So we are naming it as A, B and C. The base is BC. Since the triangle is along y-axis, the base is BC and the point B and C lie on y-axis. And the length of the sides, that is AB, BC and CA. All the three sides are of length 2a since it is an equilateral triangle. So when we know that this is the midpoint, if the sides are of the length 2a, then this has to be a, right? Since this is 2a, from the origin, this distance to C will be of length a and from the origin to this distance, that is to point B, will also be a. So a plus a whole together, it makes 2a as the base. Now when we have considered the triangle to be like this, there is also a possibility that the triangle can be this. Either triangle can be like this or it can be like this. So I have shown it in the dotted lines. So since it is an equilateral triangle, all the three sides are of length 2a. That is what is mentioned. And this data, that is OB and OC are of length a. Correct? Now we need to find the vertices of the triangle. Now these 2 points B and C lie on y-axis. On y-axis, you consider any point, the x-coordinate will be 0. Do you agree? Yes. Any point on y-axis will have the coordinate as 0 comma something. The value of y changes. Can be like this. 0 comma 1, 0 comma 2, 0 comma 3, 0 comma 4 like that. And it can be here below x-axis as 0 comma minus 1, 0 comma minus 2, 0 comma minus 3 like that. Okay, only y coordinate varies and the x coordinate will be 0. So for both point B and C, the x coordinate will be 0. So this is what it is. And let us understand what will be the y coordinates for B and C. We know this distance is a units and we know this distance is also a units, correct? It is towards the positive direction of x-axis, which is a units. The coordinate of this point will be 0 comma a. And for coordinates of point B, it will be again a units from origin. So this will be to the negative side of y-axis. That's why the coordinate will be 0 comma minus a. The distance is same but the direction is opposite. So this is plus a and this will be minus a. We have found two vertices of the triangle now. That is B and C are known to us now. Now what we have to do is we have to find the coordinate of the point A. We have already learnt in our high school that a perpendicular drawn from this vertex to the opposite side or to the base will always be the midpoint of the base. This we have already learned. So this line will be the midpoint and since it is a perpendicular, it makes a right angle here. So there are two right angle triangles formed, that is AOC and AOB. We will consider one of the right angle triangles and we will apply Pythagoras theorem to find this. What are we finding by applying the Pythagoras theorem? We will be finding this length. We know that the point A lies on x-axis. Any point on x-axis will have its y coordinate as 0. So the point A looks like some x coordinate comma 0. That is any point on x-axis y coordinate will be 0, correct? So it is some value of this distance comma 0. So we need to find this distance. We need to find OA. If we find OA, we will be able to write the coordinates of point A. This is the triangle we are going to consider for applying Pythagoras theorem. That is triangle AOC. In triangle AOC, we know AC, the length of AC is 2A, and we know this also, which is OC, length of OC is A units. This is 2 units, this is A units, and we need to find this length. That is OC square plus OA square is equal to AC square, right? So applying Pythagoras theorem gives us AC square as 2A whole square, which will be 4A square, equal to OA square as it is, plus this OC square is nothing but A square. After simplification, we get OA square to be 3A square. So OA is A root 3. Okay. When we take the square root, we generally write plus or minus A root 3. We did not write it because OA is the distance or the length. The length or distance always has to be positive. So we wrote A root 3. But there is a possibility that this can be negative. What happens if this is a negative value? Coordinates of the point A can be plus or minus A root 3 comma 0. Why did we consider minus also? Because I showed you two triangles are possible. Correct? With the given data, we can draw two triangles. That is the reason we have considered plus or minus A root 3. So the vertices of the given triangle are 0 comma A, 0 comma minus A, and A root 3 comma 0. This is the triangle which comes to the right side of the y-axis, and there is another triangle possible which is to the left side of the y-axis. So the vertices of that triangle would be 0 comma A, 0 comma minus A, and minus A root 3 comma 0. So we just found the coordinates of this and this point. Because this is positive side of x-axis, the coordinate will be A root 3 comma 0. Because this is to the negative side of x-axis, the coordinate of vertex A will be minus A root 3 comma 0. These two will remain same for both the triangles because it is the base. Hope this is clear now.